Alrighty, let's go on and move on to example number 7 here, where we have this long guy. We have log base 4 of x plus 2 plus log base 4 of 2x equals 2. And I've pasted these right here so that we can use these properties to help us solve this here. So let's go ahead and get started here. If we look at the left side here, we can see that we have a sum of 2 logs, and when we have a sum of 2 logs, we're going to use our product rule, because that means we can write it as one logarithm when we take the product, multiply those 2 guys there. So let's go ahead and do that then. So on the left side, it's now going to become log base 4 of 2x times x plus 2, and that's going to be equal to then 2. So what I've done on the left side is I took my x plus 2 and I took my 2x and I wrote that as a product right here, and I have one logarithm because I'm using the product rule right here. Okay. So now now when you have a log on one side, it's pretty common that now you write this from logarithm form to exponential form. So if I rewrite this now in exponential form, I do my base and I raise that to the power of what it's equal to. So that's 4 to the power of 2, and that's equal to this product. And I'm just going to go ahead and multiply that through right now. So 2x squared plus 4x. Okay, so what I've done here is I've done my exponential. I went from logarithm form to exponential, and again that's log, I'm just going to make this up, log base b of x equal to a. That's the exact same thing as b to the power of a equals x. These two are equivalent. One's written with a log and one is written in exponential form. So that's all I did right here. I converted from here to that guy. So now this looks like a quadratic equation that we're going to need to probably factor and all that. So I'm going to go ahead and do that there. So 4 to the power of 2 is 16 is equal to 2x squared plus 4x. I'm going to move the 16 over. Okay, so I'll say 0 is equal to 2x squared plus 4x minus 16. All right, and I kind of see that they all have a common factor of 2. So I'm just going to go ahead and just kind of get rid of that. So I'm dealing with smaller values. So 0 is equal to x squared plus 2x minus 8. All right, cool. So now we're going to go and factor this bad boy. And I've always been a fan of the diamond right here, right? Where you put the last number here on top, -8, and 2 on the bottom. 2 numbers now that give us a product of -8. And when you multiply those 2 same numbers, you add to get 2. Well, those 2 numbers would be 4 and -2, right? 4 times -2 is -8. 4 plus -2 is 2. So that's what our 2 products will be. X minus 8. Sorry, not x minus 8, it'd be x plus 4. So x plus 4 and x minus 2. Alrighty, let's try that again there. And x minus 2. All right, great. And as you can see here, I got that from this right here, right? So this 4 came right there, and that -2 came from right there. Okay, just so we have a common there. But though, these are just our factors, right? So if I want to know what is x and what is x here, well, that means that x is going to be -4 and x is going to be 2. And I got that by doing x plus 4 equals 0. And if I solve that, you subtract 4 from both sides to get -4. And same thing right here. If I did x minus 2 equals 0, I'm going to add 2 to both sides and then get 2. So the question is the answer -4 and 2? Or maybe is one of them an extraneous solution? And the only way to know is you have to go back up to our original one up here, and we need to plug it in. Okay, so remember, our first check is we can never take the logarithm of a negative number. All right, so these answers, these can be negative, but when you plug it in, you cannot take a log of a negative number. So let's take -4, right? So if I plug in right here -4, well, look, log base 4 of -4 plus 2, this right here becomes -2. You can't take the logarithm of -2. It's not possible. You're going to get an error. And we know that because even when you look at the graph, it never yields a negative value. So that's how we know that, first of all, -4 cannot be a solution. Just by doing that check right there. You cannot take the logarithm of a negative number. Now, the 2, that passes that check, right? If I plug in a 2 right here, or if I plug in a 2, you can take the logarithm of those values. But the question is, does it equal 2? And that will be our last check, is we're going to go ahead and plug in 2. Maybe we can do that right over here. So let's just plug it in. Let's just make sure it does equals 2 here. So log base 4. If I plug in 2 right here, I'm going to get 4. Plus log base 4. If I plug in a 2 right here, I'm going to get 4 again, is equal to 2. I'm going to use, again, our product rule, where if I add 2 logarithms, then that means it's going to be a product. So my product is going to be 16. Okay, 4 times 4. And check this out. Log base 4 of 16 is 2. So the left side is 2 and the right side is 2. Okay, this right here, you can think of this as 4 to the power of what is 16? Oh, well, that answer is 2. And so that's how I knew that this guy right here is 2. So 2 is the answer, -4 is not.